which is here. And if you click on here, you will see you will have route table here. So even VPC will have its own route table. Even Subnet will have this own route table. Even your internet gateway, the NATs, everyone will have their own route tables. So if you click here, it will tell you how it's connected. I hope it doesn't disconnect this time. So each route or routing rule has a destination and target. Those are the two important things it will have all the time. Each route specifies what range of addresses should be routed to which target. So if you go here, if you go a little bit, you will have destination and target. It will tell you the status. So if you are sometimes, if a user say, okay, I'm not able to communicate to one of the instances or one of the resources, always try to come and check, or are the route defined here are correct and are they active. So let's say if you have an any address in this specific range, if you got here, which is starting with here 172.31, so that it's going to hop here. It's not going to hop to the internet gateway. It's going to only hop to here, and then that destination will go to this target. So your private resources are literally separate from the public. So you'll be able to let's say if you'll be able to find it on the local network for all your other addresses you want specific. So here 172.31.0 by 16, it route request to this specific range address. In this, this is something called a CIDR block. I'm not sure if someone knows about the CIDR block, and this actually CIDR block are the one which actually specifies all the addresses. CIDR block little bit, it's called classless interdomain routing, and it's the way of allocating IP addresses or host in more efficient manner. It actually what it does is, with the cloud coming, it replaces the old kind of allocating IP addresses based on class system. You might have heard about class A, B, C. There, I think class A has got 16 million or something IP addresses. Class B has got 65,536, and class C has 256 IP addresses. So read about it a little bit on the CIDR, what it is. Normally nowadays, there is a CIDR calculator online. So people easily actually go in and calculate the range of IP addresses from there, which is quite easier. So let's say you got his here, which is 172.31.0.0.16. So any addresses starting from 172.31.0.0 to 172.31.255.255. I have calculated it. You need to route it to the local resources, only within the VPC. And the second rule specifies that route all the other IP addresses. So this rule has got a higher priority because it's on this rule has a higher priority because it's on top, and this rule has lower priority. So any addresses with this range, this rule will be executed for all other addresses here. For any other addresses, you can route it to the internet gateway. So if you want to download any patches, all other IP addresses except defined here are allowed to go on to connect to the internet gateway and get updates or patches or whatever it is. IGW here, it stands for internet gateway. We'll learn about internet gateway a little bit later on. So that's basically routing in a nutshell. And these are these are the blocks. It's called route table. You can have more communication if in there. So in a very simple term, public subnet versus private subnet. What it does is public subnet. Let's go to the, okay. So done this, you got, okay, subnet, yeah, routing. Okay, we've done this. So public subnet communication allowed from subnet to the internet, communication allowed from the internet to subnet. That is called a public subnet, and private subnet is communication not allowed from the internet to the subnet. That's the easiest way you can understand. However, for a private subnet communication, sometimes you can actually open certain, let's say you want some of the instances to connect. You can actually divert your way around. Not recommended, but if needed, if there are not high value data in there, you can actually able to divert it using the routing table itself. In order to download patches, or if you want to update anything, you are allowed to do that. But check your security things first. So how is public subnet and private subnet implemented? The most important thing to understand is that the fact that internet gateway enables internet communication for subnet. So if a subnet wants to talk to the internet, it needs to go through something called the internet gateway. Any subnet which has route to an internet gateway, that is only a private subnet. So if you look here, 0.0, that's the public subnet. That will only have anything which is in the public subnet will only go to the internet gateway. This will all fall. The whole IP address range from 31.0.0 to 31.255.255 will fall in the private range. Now, so this route, okay, this route is the internet gateway, which is allowed to the communicate to the internet. Now let's go back to the okay. Now here in the route table here, let's go to the subnets. We have when you create your subnet, when you create your VPC, you will actually have two more subnets here. When you go in here and when you create your VPC, there are four options actually. Right now it will, okay, when you use your wizard, actually it will show. Okay, where is the wizard gone? Okay, it's coming directly. We want to have the wizard. Okay, launch wizard, here it is. You got four options here. I normally use VPC with public and private subnet. So when you create this, you will get two different public and private. Right now, all the subnets are actually on the availability zone. They don't have public and private subnets specifically defined. So when you create this, you will have two different public and private subnets. So in the public subnet, if you look at the route table when you create it, the configuration for it, you can see that the subnet, that public subnet, has route to the internet gateway. However, if you look at when you will look at the other subnet, when you will create it, which is the private subnet, you will see that it does not have the route to the internet, and that is actually allowed to something called NAT. But when we look at what that is little bit later, when we look at what the NAT is, we will know actually. When you even if I think it will better if you create that VPC and give it to go, you will see actually different kind of public and private subnet. You will be able to see the internet gateway, and there will be one more instance which is called NAT instance. We will come back to you why we use NAT instance in a later scenario. But it's the route tables. But the most important thing in the route tables are the ones which decide how communication happens. You have to just understand this part, how communication happen within a subnet or VPC, and the subnet which has access to the internet, a subnet which has to be defined to the internet gateway is called a public subnet, and a subnet which does not have route to the internet gateway is private subnet. Just understand this part and create this, and you can understand actually more when you create multiple resources. You don't have to have any other information for the cloud practitioner. Now, when I was talking about this NAT instances, let me just go back to the, okay. So we did the public and private. Here it is, the NAT instance and the NAT gateway. And this is the question to ask: how do you allow instance in a private subnet to download software patches, software updates, and maybe security patches while denying the inbound traffic from the internet? Now, let's say you got a private subnet. You normally don't allow inbound traffic from the internet, but you do want to allow outbound traffic. So let's say you want to download a software patches, or you want to download a security patch. You want to apply it as well. Private subnets need a connection to the internet. Without that, that is not possible. The other scenario is, how do you allow instances in a private subnet to connect privately to other services outside the VPC? So there might be other services. You will have actually, sometimes you don't actually store RDS databases or even the S3 bucket within the same VPC. You will store it somewhere else. So at that point of time, this instances actually want to go outside your VPC defined to connect to that S3 bucket, or maybe connect to their databases or something else. So at that, so there might be services. Let's say you want to talk to even DynamoDB tables as well, or Redshift table. How do you allow instances in the private subnet to connect with them? There are three different options for us at present. The first is NAT gateway. NAT gateway is a managed service which is provided by AWS, and you can just create an instance of a NAT gateway. That's a very simple as it is. Everything else will be managed by AWS. So there is a gateway which is created in the AWS, and that's what we can use in order to have private subnet. We created earlier to have the connection to the internet. The other option is NAT instance. So instead of using the managed service, let's say you want decide to implement your own instance. How do you do that? You want to have complete control. You can define the route tables. What you do is, in that sums, you want to even create an EC2 instance, and there is a specific set of software you would need to install, and you have to configure it as a gateway. And that's the second option, but it's a longer route. You can do it if you have got many different services you have to manage. But if you've got a very small network, it will be easier to go with a NAT gateway. If you want a specific, literally restricted route everywhere, then NAT instance is a better option, but you have to manage it. You have to document each and every option, what you implement, egress and ingress rules in here. The third option is coming to the point is called egress, only internet egress, which only allow outbound traffic. And these are recommended only for IPv6. We don't have IPv6 at the moment, but when you'll have more and more IoT things coming up, because we will have more IPv6 addresses. So there are normally two kind of, you must have heard IPv4, typical IP addresses that we see right now. However, there are 4 billion IP addresses, and with the new Internet of Things, and there is a couple of other things coming out, there will be a lot of devices, so you will run out of those IPv4 addresses. Now that's the reason of new version of IP address is being introduced later on, but infrequently used. In the future, you'll expect more. So let's say if you want to use IPv6 addresses, then instead of using NAT gateway, we will make use of egress only internet gateway. For now, you don't really need to worry about egress only internet gateway. The important thing you need to remember from these steps are, if you want to allow private subnet to be able to download software patches from the internet, the way you can do it is by either installing a NAT gateway or a NAT instance. Egress only is not having more weight in the cloud practitioner exams. So don't worry about it too, because it requires more knowledge about how the traffic goes in and out. So it will be best just they have actually kept it very simple: NAT gateway and NAT instances. So let's go to the next slide. Okay, it is okay. Let me just tell you. Okay, there is this different here. Normally, who is managing the NAT gateway and NAT instances? NAT gateway is completely managed by AWS. You have to just remember these points. It will be in the documentation as well. You just need to say, okay, I need a NAT gateway, and I would just go into NAT gateway. You can create use in the network section, and AWS will manage everything else. So, and with the NAT instance, you create an EC2 instance and you define everything in there. That's the way it is. Normally, NAT gateway is created in public subnet, and NAT instance is created. I think it is both public and private, but I'll have to check. But they are both actually definitely in public, but only NAT instance I need to verify if it is created in private as well, because I saw documentation somewhere there was a debate that they can create a NAT instance in private as well now. But I'm not completely sure. Intent gateway is definitely needed for both of the NAT instance and NAT gateway. They both actually supports high availability and multi-AZ architecture. But for NAT gateway, it is fully managed. And for NAT instance, you will have to create everything, even high availability and even multi-AZ as well. So you need to keep that in mind. Now, the last topic for, okay, here is network access controlling. This is, I'll say this is actually very important concept. There was someone in the WhatsApp group who was asking about this before, where he want to restrict outbound. He want to create a private network, but was restricting some traffic. Wanted to actually access internet and something like that. I can't remember. It was last week itself. But this is a very important concept. It's called NACL, or maybe network access control is in full. What we saw earlier is EC2 instance. Okay, I only want to allow certain kind of traffic to certain kind of port. You can specify the IP addresses. You can specify IP address range as well, and then you can control the traffic in the resources using subnet. The question at that time is, how about stopping traffic from even entering the subnet? So security groups allows you to stop traffic right before it enters a specific resource, or maybe so you can configure security groups for EC2 instances, maybe for databases. They will stop the traffic from getting to the specific resource. But how about stopping traffic even entering to the subnet? So even before it enters to that subnet or maybe that zone, you want to stop a traffic. How you will do that? That's where you use NACL. You use this services. This provides stateless firewall at a subnet level. Each subnet actually must be associated with NACL. So even the subnet that we created, we actually saw earlier, which we haven't created, but when you create the VPC, they will be associated with NACL as well. And the default NACL which is created allows all the inbound and outbound traffic as well. You can even create custom initials, even create custom allow and deny inbound and outbound traffic rules as well. But when you create a new custom NACL, actually deny all inbound and outbound traffic will be enabled. And you can then actually add your rules to say, okay, which traffic it allows. But by default, it will be all deny if you create a custom one. Now, what will when we discuss normally what will happen is the other option is differences between security. Someone will say, okay, why we have different things? We can actually control traffic within security groups, so why I need to have NACL? So what is the use of a security group, and what is the use of NACL? That's again once again in a question for the internet for the interviewer. So the level at which a security group works is at the level of a specific instance. So if you create an instance, we created the diagram before on the. If you see, if you hear, if I create an EC2 instance here, this will go here inside the VPC and inside the subnet. So the level at which a security group works is at the level of a specific instance, the EC2 instance, or maybe a database or something. So you can assign it to an instance, or you can assign it to a database and maybe something else. So the traffic will stop just before this specific resource in here. So a security group is before a specific instance. So it controls the inbound and outbound traffic from this specific resource. However, the NACL is configured for a subnet. In the subnet, there might be thousands of resources. Maybe you will have, it depends on your subnet actually, you can have numbers of resources in there. So for all those resources, this NACL is applicable, and this NACL would even stop traffic coming into the subnet at all. So it will restrict, so it applies to all the traffic for all the instances in that specific subnet. And the security group, which we have seen earlier when we created the EC2 instance, only allow rules. So you cannot configure a deny rule. So by default, it's denied all. And if you configure a rule, then that specific traffic is allowed. But with the case of NACL, you can configure both allow and deny rules as well. There is a difference in here. When you say the security group is considered to be stateful. So basically what happens, what means stateful? With a security group, if incoming traffic is allowed, then the outgoing traffic is automatically allowed. So security groups only checks the rule on one side. So if you allow the inbound traffic, the outbound traffic is allowed. If you allow the outbound traffic, the inbound traffic is automatically allowed. While the NACL is stateless. You need to understand stateless and stateful very carefully. That's another question for the interviews. So with NACL, if I want to, let's say, do some communication with the device, the NACL should have both inbound and outbound traffic. Only then I'll be able to communicate. Otherwise, there'll be error. So you have to explicitly allow both incoming traffic and the return traffic. So you have to make sure you understand the difference between NACL. One is at the which levels they are, what the rules are, what the state are, and how the evaluation are. If you want, I can repeat it again. With the security group, it is assigned to a specific instance in the resource, while the NACL configured for a subnet applies to traffic to all the instances in a subnet. The rules are in for the security group is allow rules only, while the NACL is both allow and deny rules. State is stateful, return traffic for the subnet for the security group, it's stateful, return traffic is automatically allowed, while for the NACL, it's stateless, you should explicitly allow return traffic. And evaluation traffic allowed if there is a matching rule. And in the NACL, rules are prioritized. Matching rule with the highest priority wins. That's the very short comparison between the security group and the NACL. Now, let me go back to the slide. So yeah, here it is. That's the same thing I mentioned here. Security group control traffic to a specific area, so you can just read through it, and that's for that applies for NACL. So that was about it. Let me check if I want to tell you something else. There are more things about the VPC, but we'll cover it in the next one. With the rules I've gone through, there's a defense order as well with the NACL. Network ACL, the first layer of defense, whereas the security group is a second layer. So if you look at this here, NACL is outside. So that is the first layer of defense. Then something comes in, and then the security group is the second layer of defense for the inbound and ingress traffic. Now there is one more thing. One particular subnet can only have one NACL, whereas an instance or a resource within a subnet can have multiple security groups. That is another two things which I have missed to actually input, but I'll update the slides as well in there. So that is all it is. Anything else you want me to address? Oh yes, actually, there was one more thing I wanted to tell you. Learn about the IP address, the difference, how you actually use a 32-bit or the 4-octet representation of the IP address. You might have heard actually. Let me just open a word. So let's say you got an IP address of 192.168.0.1. So how do you convert this into bits? So you have to actually try to, there are many information on the internet, but try to learn this part. So how do you convert this? So IP address has got two components, the network as address and the host address. So here it is, how do you find out the bit and the octet? I'm just going to take one example. Rest you can actually go online and have a look, but do try to learn this. So if you got 192, what will happen? So 192 is very simple. Here is 1, 1, and rest is 0. What will happen to 168? 168 will be 1 here. You will have 0 here. You will have 1 here. You'll have 0, 1, 0, 0, 0. And then the next bit is 0, which is all 0. And the final bit is 1, which is all 0 except the last one. Try to understand this bit and also actually look online if you can see how the CIDR block notation works. It will help you to understand how the subnet mask, let's say you've got a 192.168.0.024. How will we, let's say you got here 192.168.0.0/24. So how many IP addresses what will be the range here? You should be able to calculate it very fast. If it is something like that, it will be 192.168.0.0 to 192.168.0.255. So you will have 256 IP addresses. From so when you will get subnet in the real-time scenario, they will say, okay, we have got a subnet and you can have this. But then you'll have to go and calculate how many IP addresses you will get. There will be some which will be reserved by some of the resources. So in real, you'll have less IP addresses, but you have to learn how to calculate this. There are different scenarios. You'll have /20 if you do here 23. Then the number of IP addresses will change. It will go to 511. So you'll get times 2, which is 512 IP addresses. I hope I'm correct. But yes, try to actually learn the CIDR block, which is very important. If you want to be a solution architect, that's the other thing you'll have to understand the difference between the IP addresses and how the CIDR block range work. Then you'll be able to work with the VPCs and the subnets and something else in further. There are many troubleshooting scenarios within the VPC. Like let's say you have configured your route table, but my Amazon virtual private cloud can't communicate with the destination. How do I troubleshoot? But those are mainly for the associate levels. You don't have to worry about it. Once you are ready, we can go through that part. Troubleshooting of the instances, connection timeout on the VPC part. Those are more complicated stuff, but yeah, we can look at it further. Yep, let me know questions, guys. Fire up. Any questions, guys? This is one of my weakest topic, but yeah.
Musa had asked the question, but I think you already have covered for it in a way.
Okay.
Right after. So, Musa, you want to go for it in case it's not been answered for you?
We'll cover. Okay, I don't think he's.
Yeah, thank you.
Okay, no worries, no worries.
Yeah, I think you covered it. Thank you very much.
Okay, no worries, no worries. So anything else, guys? There is with the VPC route table, there are best practices. To control the routing for your private subnets, you need to create custom route tables, create separate route tables for each tier. This will provide more control in maintaining the security of each subnet. And the other point of the best practice about the VPC route table is leave the main route table in its original default state. I never touch the original default route tables at all. Instead of that, explicitly, I associate each new subnet that I create with one of the other custom route tables that I have created. The reason why I do it, that is, and it ensures actually that you have explicitly control how each subnet route traffic works. There are many other best practices, but these are the two I always make sure I never touch the default state of the original mean route table.
One other quick question I have.
Sure.
So when you have an account, an original account, it comes with one VPC, I presume, right?
Yes, it does.
VPC.
Yep.
So is it always, is it a good idea to leave that alone and create a different one for whatever you want to do? Or
yes, I will always create new ones. I never touch the default ones, because this default VPCs, if you see
right,
here, they don't have public and private subnet. So let's say tomorrow you want to create an architecture which I showed earlier,
right,
that okay, we have got a private subnet, you have a public subnet, you want this to be connected to the internet, then you don't have that facility within this part. So
okay,
and even you don't know which, you'll have to go through everything, even the route tables, the subnets, everything. It's better just to create one. This is all free of charge. When you create a new one, depending on your use case, you will be presented, okay, do you want to have your resources to be accessible to some other services within the AWS or even the outside the AWS? Then you have got 4 different options here depending on the use case. I have always selected this part. I have never worked on these 2 scenarios. But yes, it's always good to create a new VPC connection.
okay. Are you able to suggest, I actually want to, as an exercise, I want to go through architecting an application with all the different components that you talked about. You mentioned the database, the EC2. The database and the EC2, they go in a private subnet, you said.
It goes in the private, yes.
And then this was actually, I'm kind of piggybacking on the previous question I had asked. So the EC2 and the database, they go in a private subnet, and then the ELB will go in the public subnet.
Yes, yes.
And then to route in between the two is you consult the routing table to do that. Is that correct? Am I correct so far?
Yes, yes.
Okay. So I'm actually looking for I'm looking for a real world example to go through to actually make sure that that concept is well understood by me.
Okay, I can quickly show you something.
Oh, that would be great.
I'm not sure if someone is running late and they can go, but I can quickly create a diagram which I was working before. Let me try. I'm sure I can remember the whole thing. So you got a VPC here. Let's see. It's going to be a little bit bigger diagram.
Are you sharing your screen?
Oh, yes, I am.
Oh, this is strange.
Let me share it again.
Okay.
Let me know once you can see my screen.
Yeah, I can see it now. Thank you.
Okay, perfect. No worries. Okay. So we got a VPC here. I'm just going to make it a little bit smaller. Okay. So we have got a VPC here. We have got users. So they are coming via maybe SSH or whatever the thing is.
Okay.
We got, let's have the internet gateway. We'll have it here because we want to access. Now we can have web traffic. Nope. Okay, there is nothing. I'm just going to just take one picture. Okay, we've got web traffic. Now let's come back to the VPC part. So you got VPC here. We'll have two subnet. So we'll keep two. So this two will be public subnet 1, public subnet 2. We'll have the private subnet here. And now we will have the EC2 instances. You can have more EC2 instances. I'm just going to, for example, I'm just going to have one. Now in here, what happens is user SSH and connects to the internet gateway and it comes in. Now what we want is load balancer. This would be a better option. Okay. And we will have a route table. We'll have a route table here. We want net gateway too. We'll remove this. We'll have net gateway here. So let's say we have got here. What we are doing is the SSH. The user is coming via internet gateway here. It's going to the application load balancer, and then it's hitting the route table. Now the route table is going to decide where the traffic is going to go. You can have a bastion host, or you can have something else here. This is the public subnet. You got net gateway in the public subnet. Now you got a security group. You want to have a security group, which you need to define here for both the subnets here, for both the instances. You can have more instances as well. You can have another route table as well to make things more complicated for you. So let's say application load balancer comes here. It will authenticate and authorize from the bastion host. It might go to the net gateway if required. So all this connection, this can internally communicate. You can have a peering connection between two VPCs, two subnets here. Sorry, not the VP, not the peering connection. You can have the connection using a route table. So both the instances in two subnets can communicate with each other. To make things more complicated, you can have this host in a availability zone separate. You can have this one in separate availability zone. So now from here, you can go as much complicated you want, depending. Well, this is created in one VPC, but you can have multiple VPCs and you can create routing accordingly. This is actually a architecture, a high availability architecture for what it was for. Can't remember the use case, but it was once again related to the application where they wanted to users to be using application within one availability zone, and then they created a multiple using the same scenario. They created the same architecture on a different availability zone just to have high availability and fault tolerant architecture. But you can create something like this if you're interested, and you can have database as well in here. You can have S3 bucket outside, so your private resources can actually communicate to that as well. You can make it more complicated you want.
Okay.
You know, the bastion host is actually a secure public instance as well, which serves SSH. So that's why we got. That's why I mentioned that SSH users are coming via SSH. So that's the reason we have the bastion host normally served to the SSH gateway.
All right. Okay. Thanks for the description.
No, that's okay. Like, this is a very simple thing you can create. I think you will be able to find architectures online as well. I think Amazon has, today I just came to know that Amazon has released many architectures along with the explanation. So you can try something from there.
Okay. I'll give that a try.
Sure. You can even convert this application to a web server as well, a web server farm kind of thing as well, where you have hosted different SQL DB in your private subnets. You have app servers in your private subnets. You can do a hybridity by creating 2 different subnets, or even extend it to the different availabilities on many things you can do. But that's a very simple architecture. I'm going to draw a line, but you can understand where it's coming from and where it goes.
All right. Oh, thank you.
No worries. That's okay. Anything else, guys? Try to if anyone is trying this architecture, try to do it by CLI as well, because there will be situations where you will not be able to get access to the console and you have to do it via CLI. Most people nowadays don't know how to use CLI, like even don't know how to describe instances or check S3 buckets and things like that. Just basic things, it's not complicated, but the practice will make it up better.
Kaushal, quick question. So today's session, is this the first one that is happening for the AWS Cloud Practitioner, or are there any other
This is the 6th session.
Okay. So where do I find the first 5? Is it on the YouTube channel?
I think it was on the YouTube. You'll have to check with Piyush or Naitik or someone else in the open consulting group.
Fred, you're on the Telegram group, are you?
Yes.
I'll post the links out there. I believe one of them we did not record, but the rest of them were recorded. So let me see where they are.
Okay, perfect. Thank you.
Okay, we'll continue VPC part next week. There are many other there are many other components we haven't covered yet. So we'll go through that, and I think we'll cover the Route 53 as well next week. And then the week after, we'll do the databases. Apart from this, I'm not sure if we require more sessions, but if you want to, if you are learning something and if you have queries, I think last year we had more interactive sessions. People were coming up with so many questions than this year. So yeah, try to do some online research and come up with some questions, so we can have more session where I can just answer your questions instead of just going through the sessions. I don't see questions in the group as well, except I think there are 4 or 5 people who are constantly communicating with me via WhatsApp. And they are definitely studying very hard towards the certifications. So let me know, guys, if you need any further help.
Cool. Well, thank you. I believe, Kaushal, somebody has posted that he has achieved the certification in the group today, right? So. Okay.
Oh, it was a couple of days back.
Yeah, sorry.
Yes. He was, I think he was in the previous, he was studying since last year, but he never got a chance to finish it.
Yeah.
But the problem is, Naitik, I will try to tell everyone, there are many people who has got certifications, but they are not able to perform during the interviews. And that's where people are lagging. I have conducted more than 50 interviews in the last 4 months. I'm not an expert in AWS, but at least there are other people who are architects since about 4-5 years. And the main problem is that people has got certifications, but they are not able to even describe best practices you will implement while taking one resource, while maybe let's say EC2 instances best practices, or maybe IAM user best practices, or maybe security group and NACL best practices, which we covered earlier. So they're not able to differentiate just basic things. So yeah, clearing exam is like you go through that course and you'll be able to clear it. But the main thing is they're not able to research the architecture and come up with questions. Now for me as well, it is like, some of these things are very, very fundamental, because I don't work into hands-on scenarios anymore. But yes, I'm happy to take up that challenge as well and see if someone can come up with a scenario and ask questions and learn the architecture. That's the very important thing if they want to get into cloud engineering or something like that.
Right, and thing is, it has to do with the real experience versus the theoretical knowledge.
Yes.
So that I mean, that person has posted in the group that it's better to do some bits like practical experience helps more.
Yes.
And I think we might enhance this basically within this forum. Basically, well, probably once this course is over, we'll do something basically to offer this building something. So that we'll ask guys to basically do research and come up with approaches and all.
Yeah, if they come up with any even questions, regarding the architecture, that's better as well. It shows, like, I except this 4 or 5 people, I don't see anyone in the group as well. They are feeling a little bit shy to post in the group, but I was like, just go ahead and just post it. The questions are definitely stupid, some of them, but yeah, they are new to IT and they are doing their best. So I don't tell them that these are stupid because I try to answer them. But that's the other thing. Because other people are not posting, they are thinking, okay, yeah, other people are not posting. I'm not sure how awkward will I feel and things like that. But yeah, they are doing their best. I think there's one guy, Prithvi, I know, Sapan, I know, they are doing very, very good. They are not from IT, and they are quite ready. They are actually not preparing just for exam. They are preparing for the interview. They're preparing themselves to face the interviews. So yeah, they're doing best. They're doing good.
Cool. I mean, I'll share the same thing on the group forum tomorrow when everybody picks it up.
Sure.
Thank you very much for your time, Kaushal.
No, that's okay. That's okay.
And we'll probably do some initial tests, some sort of test next week, I guess. Right?
Sure. Yeah, if someone wants to actually try to create this VPC, there is a documentation on AWS as well. If you search for creating a VPC with public and private subnet for your computing environment, you will have the whole tutorial there. How to create a VPC step by step. Okay, guys. No worries. Have a nice evening.
Thank you. And
See you all next week.
good night, all.